Our origin story says we came from the Big Bang, and the Big Bang came from nothing. But is it ever possible for something to be born from nothing? Scientifically, nothing means absolute zero with not a single particle moving. For example, our universe is full of stars, galaxies, cosmic rays, neutrinos, radiation, matter, antimatter, dark matter, and dark energy. Suppose we were somehow able to take away all of them and make everything totally empty, like a vacuum. Even in this artificial emptiness, the universe would still keep expanding and producing radiation. There's always something around, even in places that look empty. This happens because of quantum fields, which create a kind of hidden energy that keeps things from being absolute zero or truly empty. And it suggests, before the Big Bang, there must have been some kind of energy or radiation, as it couldn't be empty. And the idea of nothing is not real, it's nothing but a concept. Now you must be thinking, if not nothing, what could be there even before the Big Bang? I just have one for you: inflation. The concept is almost the same as it is in economics. Let me break it down for you. Before the Big Bang, the universe was expanding really fast. It was getting bigger and bigger at an incredible rate. To give you an idea, if you started with a universe smaller than an atom, it would become way bigger than the whole observable universe we know, with its 350 billion galaxies, in less than a tiny fraction of a second. But this rapid expansion stopped at some point, and all the energy that helped the expansion filled up space. Think of it like a balloon. Now, it heated up and created the particles that make up everything we see, like stars and galaxies. This event is what we call the Big Bang. It might sound like a sci-fi or fantasy, but it's the current understanding in cosmology. But here the major questions come. What really caused the inflation to start? And what made it stop? How long did it last? And as you guessed, unfortunately, we don't have all the answers to those questions yet. But how did scientists know about this? Long ago, scientists noticed some strange things that didn't match up with the idea that our universe started from a super hot, dense point. They came across three big puzzles. One of them was the horizon problem. Imagine parts of space that are really far apart, but somehow have the same temperature and density. Since the Big Bang, they haven't had enough time to share heat or information to attain thermal equilibrium. Then, how did these far-off places end up looking so similar? Next comes the flatness problem. When the universe expands, gravity should make it curve in on itself. But when we look up there, it's amazingly flat. Why does it seem to have started just right to stay flat? And lastly, they have the monopole mystery. Back in the early days, the universe was super hot, cooking up exotic stuff like special neutrinos and magnetic monopoles. But now, nowhere to be found. What happened to them? So these are the things that raise doubt about Big Bang. Now, let's rewind to the beginning. Picture this tiny, ultra-dense ball-like atom that explodes and grows, creating everything we know: stars, planets, and all. But what came before that explosion? What was the universe like then? Before the Big Bang, the universe went through a crazy growth spurt, expanding at mind-blowing speeds thanks to a strange energy filling empty space. This expansion happened so fast, leaving the universe vast and chilly. Only after that did the intense heat of the Big Bang kick in. Some theories say this expansion didn't just stop all at once. It slowed down in spots, and every time it paused, it might have birthed a new universe. These ideas, like the eternal inflation theories, suggest we might not be alone. There could be countless other universes popping up all the time. Yes, it's the multiverse I'm talking about. But what does all this mean? Roughly speaking, if cosmic inflation is correct in describing what happened before the Big Bang, it might mean we can't ever fully know where everything came from. It's like chasing a mystery that keeps getting bigger because we don't understand what came before inflation, and we might never figure it out. Some scientists think there could be many universes, maybe even an endless number, which is a pretty mind-blowing idea. Now, here's something else to think about. If multiple universes really exist, some theories suggest that things like gravity, light speed, and particle masses can be different in each universe. So why does our universe seem so perfect that it has a life form like us or other creatures? Why do we have stars producing elements like carbon and oxygen that are crucial for life? Mainstream cosmology supports the idea of inflation, the super-fast expansion before the Big Bang. This could lead to multiple universes, which is a legitimate scientific idea that scientists are actively studying. Inflation hints at a time before the Big Bang when space was stretching with energy, and other theories explore how extra dimensions might have influenced how the Big Bang happened. Now, imagine there are ideas about our universe floating in space, and there could be other universes floating around too. This suggests there are more dimensions in space than we can see. It's like we're on a small sheet, which is called brains, floating in a vast multiverse. Now, think of it like many balloons are floating in the air randomly. It's likely that any two balloons would bump into each other, isn't it? That way, what if these universes bump into each other? One theory suggests that the Big Bang happened when two of these sheets or brains collided and then moved apart. When they collide, they create a lot of heat, kind of like a big explosion on that sheet of space and time. So this is another idea about what might have happened before the Big Bang. Brains crashing into each other and causing big bangs. Now, these multiverse theories might sound like wild guesses, but they actually have math behind them. Also, theories explaining the very beginning of the universe have evidence from experiments. The key to all of this is something called the cosmic microwave background radiation, or the SEM. This is the oldest light we can see in the sky, coming from about 380,000 years after the Big Bang. At that time, the universe cooled down enough for atoms to form, making the universe transparent. Since then, this light has been traveling through space. We have a satellite named Planck in orbit right now, which has been taking detailed pictures of this extreme ancient light. It's like looking at a baby picture or a scan of the universe when it was very young. By studying this light, we can learn about the early universe's structures and properties, giving us clues about what happened at the beginning of time. Modern physics relies on two main theories, Einstein's general relativity and quantum theory. To understand how the Big Bang happened and what occurred before it, we need to combine these two theories. Only then can we hope to answer big cosmological questions like what space, time, and the universe are, and where they came from. The farthest things we can see in space are 47 billion light-years away. This makes the observable universe about 94 billion light-years wide, speaking of diameter. Now, you might ask a beautiful question here: how the observable universe can be bigger than the time it takes light to travel, since the universe is only about 13.8 billion years old. The reason is that the universe has been getting bigger over time, pushing distant things even farther away from us than the time it takes for their light to reach us. Most scientists believe that the universe is much larger than what we can see. But is there anything beyond the entire universe? Is there anything outside of it? Probably not. We strongly suspect that our universe might be endless, but this is just what we suspect. Even now, parts of the universe exist far beyond what we can see. Why do we think that? Well, our universe has been around for 13.8 billion years. Light from the farthest reaches of what we can see has only had that much time to reach us, so we can only see as far as light has traveled. How far it goes is a big question we still don't have a definite answer to, but it's possible that the universe goes on forever. Considering what we've recently learned in physics, we tried to answer some big questions. What was there right before the Big Bang? How vast is our observable universe? And what exists beyond what we can see? But are we missing something important? After pondering the beginning of everything, a natural follow-up question arises. How will the universe eventually end? Well, the current best idea is that it will keep expanding endlessly. The reason for this is because the universe is actually speeding up in its expansion, which is quite puzzling. Previously, we assumed that gravity always pulls things together. With all the galaxies out there and the universe expanding since the Big Bang, we thought it should slow down at least. There was even a question about whether there's enough matter to stop it and make it collapse back again. However, for the time being, it looks like the universe will just keep expanding endlessly. So, what do you think might have happened in those primordial moments? Could alternative theories hold the key to unlocking these cosmic secrets? Share your thoughts in the comments below, and don't forget to subscribe for more mind-bending explorations into the unknown. Thanks for watching.